Good day to all of you. Welcome to Easy Physics. Learn physics as easy as 1, 2, 3. Today's video is mainly for students of class 11th, and if you want to study the basics of physics, you can also watch this. In this video, I'll be explaining about the systems of units, which is the first topic of the lesson, units and measurements. Before we begin, do you ever thought, why do we need units? What is the purpose of units? If, for instance, if you want to measure a wooden board for building a house, you need to purchase it from someone who doesn't really know what your requirement is. Numbers by themselves don't make any sense. That is, if you say, I want a board which is 350 long, what? Or units by themselves also don't make any sense, right? If you say, I want a board which is meters long, doesn't make any sense, right? But if you say, I want a board which is 4 meter long and 2 meter wide, your information is very correct, and the person will be able to help you by providing a proper wooden board, right? That is, in order to make sense, all the measurement, it is not only about length, any other physical quantity, any other measurement need both a number and a unit. Important. Now, when you come to the measurements, there are n number of measurements which we will be dealing. Out of that, 3 of them are categorized as basic types of measurement in physics. One is mass, which measures the amount of matter in an object. Second one is length, which measures the distance between objects. And the third one is time, which measures the duration between two events. Even though these are classified as the basic types of measurement, there are n number of another measurements which we will be dealing, as I told you. For example, area, volume, temperature, density, pH, force, pressure, resistance, voltage, current, magnetic field. There are n number of other measurements which we will be using. As you know, in physics, as you might be knowing, that from smaller classes we have been instructing that in physics we have to describe all the quantities in terms of SI system. SI system means it is international system of units which is accepted and adopted worldwide by scientists. Before we go into what is SI system, let us be familiar with the other systems of units which are in use. The first one being the CGS system. In CGS system, we have 3 basic measurements: length, mass, and time. Length is measured in centimeter, mass in grams, and time in seconds. That is why the name CGS, centimeter, gram, seconds. The symbolic representation of centimeter is cm. That is, for example, if somebody writes 25 cm, you should be able to read it as 25 centimeter of length. The second system of unit is the MKS system. In this also we will be using 3 basic measurements: mass, length, and time, and their units are meter, kilogram, and second. Meter, we will be using the symbol M, kilogram kg, and seconds S. The third system is the FPS system. By now you might be in a position to guess what it is going to be, right? FPS system means in this also we will be using the 3 basic measurements: length, mass, and time. In this, length is going to be measured in foot, mass in pound, and time in second. Then SI system, which is the system which we have to follow while studying science. Okay, because this is a system of units which is accepted and adopted worldwide. The uniqueness of this system in comparison with the other 3 is, in addition to the 3 basic measurements, we will be using 4 more measurements in SI system, which is considered as the basic units. That is, in SI system, there are 7 fundamental quantities and their units. They are length. Its unit is meter, represented symbolically by using the letter M. Mass, kilogram, represented by kg. Time is seconds. Unit of electrical current is ampere. Temperature is Kelvin. Amount of substance is mole, and luminous intensity is candela. So in SI system, these are the 7 fundamental quantities which we are using: length, mass, time, electrical current, absolute temperature, amount of substance, and luminous intensity. Since this is a system which is adopted by scientists all over the world, all these measurements has to have some accuracy. And for that, all these units are given specific definitions by International Bureau of Weights and Measurements. It is followed as it is. Meter is the first system of unit. Definition of meter goes this way. That is, it is the distance traveled by light in vacuum in a time interval of 1 by 299,792,458 of a second. This distance traveled by light in this much duration is defined as 1 meter. Kilogram is defined this way. It is the mass of international prototype of the kilogram kept at the International Bureau of Weights and Measures in Serres, France. Definition of second. Second is SI unit of time. This is a duration of 9,192,631,770 periods of radiation corresponding to the transition between two hyperfine ground levels of the cesium-133 atom. Definition of Kelvin is this. It is a fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Definition of 1 mole is this. It is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon-12 molecule. Definition of ampere is, it is a constant current which is maintained in two straight parallel conductors of infinite length of negligible circular cross-section and placed 1 meter apart in vacuum would produce between these conductors a force equal to 2 × 10⁻⁷ Newton per meter of length. This is how 1 ampere is defined by International System of Units. The next one is definition of candela. It is defined as the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 × 10⁻12 Hertz, and that has a radiant intensity of 1 by 683 watts per steradian in that direction. So this is how all the 7 units which is used in SI system is been defined. As per the system international, in addition to these 7 fundamental quantities, there are 2 supplementary quantities and their units also. The first one being plane angle, its unit is radian, symbolically represented by using the symbol RAD. Second one is solid angle, its unit is teradian, we'll be using the symbol SR to represent it. It is also having a proper definition by System International. It is 1 radian is obtained in an arc with length equal to 1 meter, whereas steradian is defined as a solid angle subtended at the center of a sphere of radius r by a portion of the surface area of the sphere whose area is equal to r square. Now, why we use the SI system? Why not the other systems? What is wrong with them, right? Scientists use the SI system worldwide for 2 reasons. The first one is measurements are easily understood by all the scientists because for each of these units, there is specific definitions given so that accurate measurements are possible. The second reason is measurements are easier to convert than the English system. English system is the FPS system. Let us see what makes the conversion in SI system easier and what makes the conversion in English system a little tougher. The reason is in the FPS system, you have to memorize so many numbers. For instance, 12 inches in a foot. So when you convert foot into inches, the number 12 has to be there in your mind. Or if you convert yard into feet, 3 feet in a yard. So another number, 12 is one number, 3 is another number. Then if you want to convert feet in miles, then you should remember a third number, which is 5,280, because in a mile, there are 5,280 feet. Or if you want to convert ounce in pound, then 16 ounces are there in 1 pound. Or if you want to convert volume of quarts to gallon, you should remember the number 4. That is, there are 4 quarts to a gallon. So depending on the different quantities and depending on the different conversions, you need to memorize so many numbers. But in SI system, you only have to remember one number. Whether you are converting from smaller to bigger, whether you are converting units of length or mass or volume, you just have to remember one number, which is the number 10, because SI system is following metric unit conversion system. Metric conversion means you can have powers of 10 to convert from bigger to smaller or from smaller to bigger units. We'll see some of the prefixes. It is not all. Some of the commonly used prefixes which is used in SI system. The first one is kilo. Kilo means 1,000. For example, if you want to convert kilogram to gram, just multiply with 1,000. If you want to convert kilometer to meter, multiply with 1,000. If you want to convert kiloliter to liter, multiply with 1,000. So it is very simple that you just have to study the prefixes and the conversion in terms of tens power. Hecto is 100. Deca is 10, unit means 1, which means 1 meter is 1 meter, right? Deci is 1 by 10, centi is 1 by 100, milli is 1 by 1,000. So if you are converting centimeter, kilogram, liter or anything, maybe ampere, milliampere to ampere, you just have to divide with 1,000. So any quantity, by knowing these prefixes, conversion will become easier, but it is not true for the English system. It works for all the types of measurements. For example, if you're measuring mass, then it is gram, or you can write centigram, milligram, etc. So these conversions are applicable for mass. If you're measuring length, then meter, kilometer, decameter, etc. All these units, you can use the prefixes, whether it is mass or length or volume. If it is volume, then liter is the unit. You can use deciliter, hectoliter, etc. as the another units, bigger or smaller units. The first part of the term indicates the amount, that is centi, means it is the amount. The second part indicates the type of measurement. If I write gram, centi means it is the amount. If I'm using gram along with it, means it is measurement of mass. If I use centimeter, meter is measurement of length. So it is easier to convert smaller and bigger units in SI system. That is one greater advantage. How does converting units work? Let me show you an example how to convert SI system. As I told you, it is very easier because it is involving only one number. It is 10. For example, in the English system, if you want to know how many inches in 2 miles, what would you do? First, you have to take the number 2 and then multiply it by the number of feet in a mile, that is 5,280. Then multiply the number of inches in a foot, that is by 12. So many multiplication after that, you'll be getting the result as 1,26,720 inches in 2 miles. Too complicated, right? The number 2 and the result 1,26,720. The numbers itself have changed a lot and you have to undergo so much of calculation process. But if you want to convert an SI system, say for example, how many centimeters are there in 3 meters? What you have to do is you just have to write kilo, hecto, deca, unit, deci, centi, milli. These are the sequence of units in SI system. And first step is find out the unit you have. It is what? Meters. 3 meters to centimeter, right? Second step, you find the unit you're changing to. You're changing to what? Centimeter. So between these, how many units are there between? See, when you look into meter and centimeter, there are 2 units between. That meter is the unit and centi is what you're going to convert. So 1 and 2 units. So add as many digits, as many zeros towards the right. So you will be getting 300 centimeters because you are changing towards the right. So add as many zeros towards the right. So 3 meters means 300 centimeters. The same thing will work. More conversions if I ask to convert 2321.0 millimeters to meters. So your unit is milli. You're going to convert it into meter. So how many points? 1, 2, 3. So shift the decimal point 3 times towards left. So which means the decimal point has to be placed here and you will be getting the result as 2.321 meters. If you want to convert 521 grams to hectograms, see, grams is a unit, hecto is 1 and 2 times backward. So shift shift the decimal point 2 times towards left, you will be getting the result as 5.21 hectograms. Or if you want to convert 8.5 kiloliters to centiliters, kilo is your unit, you want to convert it into centi. 1, 2, 3, 4, 5. So you should shift this decimal point 5 times towards the left. So when you shift to 1 times, there is no other point, there is no other digit present, which means add 4 zeros. So your result will be this. The digits are not changing here, only the position of the decimal point is changing. So I hope this understanding of systems of units is very, very clear to all of you. What all things you should remember now? It is all the measurement need a number and a unit. The CGS, MKS, FPS, and SI systems are the systems which we have discussed today, and how to convert from one system to another system in metric units, because you don't have to bother about the English system. In physics, furthermore, we will be using only the SI system. Hope today's class is very useful to all of you and you have a very clear understanding about the systems of units. Thank you for watching. Take care. Bye bye.